Hello everybody, and welcome to this video on writing ionic equations. Through this video, I will be showing you how you can construct a net ionic equation from the chemical equation. So let's begin. For this video, I will be going through with you 4 different types of reactions. Firstly, a precipitation reaction. Secondly, a neutralization reaction. Thirdly, an acid-metal reaction. And lastly, an acid-carbonate reaction. So let's start off with the precipitation reaction. Now, in this example, I have lead 2 nitrate, which is dissolved in water, to release Pb2 plus and 2 NO3 ions, as you can see here. On the right hand side, I have potassium iodide dissolved in water to release potassium and iodide ions. Now, a chemical reaction will take place when these two solutions are mixed together. And if you recall from your assignment 3 done in semester 1, a yellow precipitate should be formed, which is PbI2. So let's take a look at the chemical equation. So we remember that lead 2 nitrate will react with potassium iodide to give you lead 2 iodide and potassium nitrate. Now, how do we construct an ionic equation? Firstly, we have to look at which are the aqueous compounds in the equation. We first need to identify all the aqueous compounds in both the reactants as well as the products. So in this case, lead 2 nitrate is aqueous, potassium iodide is aqueous, and potassium nitrate is aqueous. Now, what do we do with these aqueous compounds? Now, as you can see here in the diagram, we observe that these compounds, when they are in the aqueous state, they actually dissociate into their corresponding ions. Therefore, in the ionic equation, we will split up the ionic compound, the formula of the ionic compound, into its individual ions. So for the total ionic equation for this reaction, we will first look at lead 2 nitrate. So lead 2 nitrate will be split up into Pb2 plus Aq plus NO3 minus Aq. Now remember, there are 2 nitrate ions, therefore we need to have 2 nitrate ions. Similarly, for potassium iodide, the stoichiometric coefficient is 2, therefore it will form 2K plus Aq plus 2I minus Aq. And that is it for the reactants. Let us now look at the products. For the products, here we have PbI2 solid. Lead 2 iodide, as it is a solid, it will not dissociate in water. Therefore, we will keep it as PbI2 solid in the ionic equation. Lastly, we will look at potassium nitrate. Remember, it is an aqueous compound, therefore we will split it up into its individual ions. So this will form 2K plus as well as 2 nitrate ions in aqueous state. Now at this point of time, I want to introduce this term known as spectator ions. Now, what do I mean by spectator ions? Now let's try to think about what spectators do at a match. For example, a football match. Now, in a football match, the spectators simply sit by the sides and watch the match take place. Regardless of the number of spectators or the identity of the spectators, so I don't care whether I have 50 spectators or 50,000 spectators. I also don't care if the spectators are the Sultan of Brunei or Prime Minister Lee. It doesn't matter, because the spectators will simply sit by the side and watch. They will not participate in the match, nor will they affect the outcome of the match. Therefore, we call them the spectators. Now, how does this apply to the writing of an ionic equation? So let's go back to the ionic equation. Now, here in an ionic equation, we will also want to identify the spectator ions. Therefore, with the total ionic equation, we will first have to identify the spectator ions, because they do not participate in the reaction, they do not react. Before and after the reaction, they remain the same. Therefore, they are to be ignored and cancelled out from the total ionic equation, so that we can actually see what is actually going on in this chemical reaction. So to identify spectator ions, we will need to look at which ions appear in both the reactants as well as the products. So let's look at this equation, the ionic equation now. Alright, let's look at the reactants in purple. Now, let's first take a look at Pb2+. Now, Pb2+ appears in the reactants, but if you look at the products in green, we do not see Pb2+ anywhere. Therefore, it is not a spectator. It cannot be cancelled out from the ionic equation. Now, what about for nitrate? Now, nitrate, if you look carefully, it appears in the reactants. It also appears in the products. Therefore, before and after the reaction, there is no change in the nitrate ions. Therefore, it is a spectator ion. Therefore, we will cancel out the spectator ion from the total ionic equation. Next, let's look at potassium. Now, K+ appears in the reactants. It also appears in the products. Therefore, there is no change to the potassium ions. It can be cancelled out. Lastly, for iodide ions, it is present in the reactants, but not present in the products. Therefore, it is not a spectator ion. It cannot be cancelled out. Therefore, the net ionic equation for this reaction is actually Pb2 plus Aq plus 2I minus Aq to give you Pbi2 solid. And ladies and gentlemen, this is your net ionic equation. Right, let us now move on to the next example. Now let's take a look at this. This is an acid-base neutralization reaction. Alright, here we are using sulfuric acid with sodium hydroxide to give you sodium sulfate as well as water. Now remember, for the total ionic equation, we will have to split up all the aqueous compounds. Okay, so therefore here we have split up the sulfuric acid, we have split up the sodium hydroxide, we have also split up the sodium sulfate. Water is in the liquid state, therefore it remains as it is. Next, we try to find out which are the spectator ions. Now, H plus appears in the reactants but not in the products, right? Therefore, it is not a spectator. Sulfate appears in the reactant and the products. Therefore, it can be cancelled out. Sodium appears in the reactants, also appears in the products. It is therefore a spectator and can be cancelled out. Lastly, hydroxide appears in the reactants but not in the products, therefore it is not a spectator and cannot be cancelled out. Therefore, the net ionic equation is actually 2H plus AQ plus 2OH minus AQ to give you 2 water molecules. Now, as you might have noticed, the stoichiometric coefficient is the same for all reactants and products. Therefore, this can be simplified by cancelling out the 2, and therefore the final net ionic equation will simply be H plus OH minus to give you H2O liquid. And ladies and gentlemen, this is your net ionic equation for a neutralization reaction. Now, what about in the case where the reactants are not all in the aqueous state? In this example, we are looking at an acid-metal reaction where one of the reactants, right, is actually a solid. Now, none of the rules have changed. Okay, now let's look at this. We are looking at magnesium reacting with hydrochloric acid, right, to release hydrogen gas and forming magnesium chloride in the process. So here there is no change to the rules. Magnesium, because it is a solid, not an aqueous compound, we leave it as it is. Here HCl is an aqueous compound, we will split it up. Please don't forget the stoichiometric coefficient, okay? And of course, for the products, it will form Mg2 plus AQ plus 2 Cl minus AQ. Hydrogen is a gas, therefore it will remain as it is. So the net ionic equation, again, can be obtained by comparing the reactants and the products. So as you can see, the only spectator ion that can be identified between the reactants and the products is only the chloride ion, because it appears both in the reactants and the products, isn't it? Now, therefore, this can be cancelled out, and the net ionic equation will simply be Mg reacting with 2H plus to give you Mg2 plus AQ plus hydrogen gas. And this is your net ionic equation for this reaction. Finally, this example will be slightly more complicated, but the rules are exactly the same. Now for an acid carbonate reaction, okay, again we write out the balanced chemical equation, including the said symbols, okay, and we split up all the aqueous compounds into their individual ions. So as you can see here, the total ionic equation is this, and we can now compare the reactants and the products to look for spectator ions. Once again, the only spectator ion that we can identify in this case is the chloride and in the reactants and the chloride in the products. So therefore only this can be cancelled out, and therefore the net ionic equation will simply be calcium carbonate reacting with 2H plus to give you Ca2 plus AQ plus CO2 gas plus H2O liquid. And there you have it. This is the net ionic equation for this acid carbonate reaction. Right, so this concludes this video on writing ionic equations. I hope it has been helpful for you in learning how to write an ionic equation based on the 4 examples that have been provided.